The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for attending our webinar today. My name is Andrew Knight. I'm Technical Sales Manager here at Lambda, and I have with me Dave Jacobson, our Senior Apps Engineer, who will be presenting today. And today we're going to talk about and do an overview on how to get started using TracePro to develop and analyze an illumination system. I'm going to leave all the instructions about how to ask questions with David since he covers it in the webinar, and I would just like to thank you again for attending. And with that, I'll turn it over to David.
Thanks, Andy. Again, welcome everybody to our webinar today. The format of today's webinar is going to be a 25 to 30-minute presentation followed by a question and answer session. At any time during the webinar, if you have a question, please feel free to submit it using the question box in the GoToWebinar control panel. And then we'll address all questions at the end of the webinar. And I'll remind you about this a few times as we go along during the webinar today. Before we get started, I always like to mention some of the other resources that are available to help you learn more about TracePro. The first is our past webinars. Now, each time we do one of these webinars, we record it and we save the archive version or put it up on our website along with the slides and any relevant examples. These can be found in under the technical support section of our technical support section of our website, and then webinars. There's also tutorial videos available from our website, as well as more traditional tutorials where you can download, print out, and then follow them along step by step. You can also find information on our upcoming TracePro training classes on our website. And with that being mentioned, we do have 2 training sessions coming up here in the near future. The first is in Jena, Germany, from September 17th through September 19th. The first 2 days will be an introduction to TracePro, and the third day is we're calling Advanced Topics in TracePro, where we'll be covering stray light analysis, the scheme macro language, and optimization. Then we also have training here in Littleton, Mass. at our headquarters. We'll have 2 days of an introduction to TracePro, September 30th through October 1st. And then we're going to have a full day course on optimization with TracePro on October 2nd. All these courses still have space available. If anybody's interested in attending, just drop us a note or contact us here. We'll be happy to send out some information. I should note that the 2 courses that are in bold, the Advanced Topics with TracePro and the Optimization with TracePro, I will feature optimization. So if you're interested in learning more about optimizing in TracePro, check out one of those 2 courses. The current release of TracePro is TracePro 7.3.6. This was released on August 15th of this year. So anyone with a current maintenance and support agreement is encouraged to download and install this newest release of TracePro, and you can do that from our website. So with that out of the way, let's get started with today's webinar. Looking back at a lot of our webinars, they've been aimed at more advanced topics, things such as optimization or the reptile properties of the scheme macro language. So we thought it might be a good time to actually do a webinar, a very basic webinar, on just how do you get started with TracePro, building your first model, running the ray trace, defining properties, and looking at some of the results. So that's what we're going to do today. We're going to include, as we go along, a live demonstration as well. So the topics of today's webinar, well, as I just mentioned, will feature a live demonstration of setting up and analyzing a model in TracePro, including building the geometry. In this case, I'll show importing geometry from another model, as well as building geometry within TracePro itself, applying surface and material properties, inserting a ray file into the model to use as an LED light source. Fairly often we get asked, how do you use ray files in TracePro? So we'll be able to show that in this webinar. Then we'll just show running the ray trace. And lastly, we'll analyze the results. And then we'll wrap it all up again with the questions and answer session. So once again, any questions throughout the webinar, please feel free to submit them using the question box on your GoToWebinar control panel. So before we get started, I'd like to talk about some different workflows in TracePro and sort of what the typical workflow is. The most typical, most common is you create the geometry, apply properties, define the sources, run the ray trace, and then analyze the results. And you can then iterate back through to any step if you need to make changes. If you're working with an external or a separate CAD program, say SolidWorks, Pro Engineer, CATIA, Inventor, well, you can then create the geometry in that program, export it to TracePro as an SAT, STEP, IGES file, and then in TracePro, open that model, and now apply the properties, define the sources, run the ray trace, and analyze the results. So you're taking advantage of the CAD properties and the CAD generation of your full-time CAD program, and then just using TracePro for the optical end of things. If you're a SolidWorks user, we also have the TracePro Bridge for SolidWorks option. And what this does is you're once again creating your geometry in SolidWorks, but now the TracePro Bridge allows you to apply all the optical properties and define your sources in the SolidWorks environment. And then these are saved as part of that SolidWorks model. And from SolidWorks, you then export a TracePro file for analysis in TracePro, where you run the ray trace and analyze the results in TracePro itself. The advantage of this is that because you're applying those properties and saving them as part of the SolidWorks model, you don't have to repeat that process when you bring the model into TracePro. So if you go back to SolidWorks, make changes, modify the geometry, the properties are still there, so you don't have to spend that time bringing the model back over and redefining those properties in TracePro. It's a good way of saving time. There's also, in TracePro Standard and Expert, our interactive optimizers. And actually in TracePro LC, we have the geometry creators, which are the optimizers without the optimization capability. And here you can create geometry in these optimizers and then send it from there to TracePro, where you then apply properties, define the sources, run that ray trace, and analyze the results. So it's another alternate workflow where you can create geometry not necessarily directly in TracePro. So as I mentioned, the largest portion of this webinar today is going to be a live demonstration of building a model from start to finish. And here's the model we're going to work with. We're going to have two lenses. We're going to put those inside of a lens barrel, control stray light, block some extra light. They're going to focus the light onto a light guide. This light guide starts off and then it bends 90 degrees around a corner. And then we put a target here at the output surface of the light guide so we can analyze the results. And in this case, our light source is going to be a ray file. We're going to insert a ray file from an LED manufacturer into the model to use as the source. And we'll build this model up from scratch here as we go now. So with that, I'm going to go over to TracePro and we'll start working on that model. So here's the finished product. I'll turn the rays off. And we can see our lenses, our lens barrel, our light guide, and our target. In this case, I have ray sorting turned on, and I'll show that once we've run the ray trace. So I'm only seeing the rays that are hitting my target surface. So to get started on this, I'm going to open a new model window and go to File, Open. File, New. Now the lenses I'm going to use in this model are actually off-the-shelf catalog lenses. In this case, it's going to be a Melz-Griot lens, but from our website you can download lens catalogs from manufacturers such as Melz-Griot, Newport, Edmund Optic, and several others. So I'm going to open a model window here. I'm going to go to File, Open, and I'm going to use this LAG 119 lens. This is a Melz-Griot. The model number is LAG 119, and it's an aspheric condenser lens. We can see here, here's our lens, and then here's an object or a target at the focal point of the lens. And this is what you'd open up when you open up one of these catalog lenses that you can download. So what I want to do is I'll note here too that the material property is already defined. It's shot B270. Now I want to insert this lens into my new model. So I'm going to select Object 1, and on my keyboard I'm going to do Control-C, come to my new model, and do a Control-V. So we're copying the lens using the Windows clipboard. And note here the material property is copied along with the lens. And I'm going to close this model. I don't need that one anymore. Now the first thing to note is, let me turn this so it can be seen a little easier. The lens is in the wrong position, and it's also oriented wrong, so we're going to change that. I'm going to do a right-click and choose Properties. Correction, I'm going to do a right-click and choose Modify. And I want to change the position. So I'm going to set the position to be 38.4 along the Z-axis. And I also need to rotate the lens. So I'm going to rotate it about the X-axis 180 degrees and click Modify. So now the lens is in the correct orientation and position that I want it to be. I still need to add a second lens. So I'm going to do a right-click here, and I'm going to choose Move. And I'm just going to click Copy. And what that's going to do is it's going to create a copy of that lens right in the same spot where the previous one is. So I'm going to choose the copy here. Again, I'm going to do a right-click and Modify. And I'm going to change my Z position to 61.6 millimeters. I'm going to take that rotation off. And then click Modify. Or, sorry, click Insert. No, Modify. So now we have two lenses, proper orientation, proper position. I'm going to change their names. Makes it easier to see. You just double click on the object name and type in a new one. And once again, we see both of these still have the same material property, shot B270. I'm going to save this. Just always a good idea to do. Let's call it Afternoon Session Model. So the next step in our model is we're going to insert this lens tube here, or this lens barrel to block any stray light. And I'm going to use that using the Insert Tube option here in TracePro. I'm going to call that Baffle Tube. The wall thickness, I'm going to leave it at 1 millimeter. My length is going to be 75 millimeters. The ID of this tube is 15.75 millimeters. And I'm going to leave my base position and base rotation as they are, 0, 0, 0. I'm going to click Insert. So here's our hollow lens tube. The 15.75 millimeter inside dimension matches that of the lenses. So I got that by looking at the lenses themselves. I should note I've built this model before, so the positions aren't necessarily arbitrary. So I did spend a little bit of time putting everything together before running through this webinar. So my next step, I want to add the light guide. And the light guide we're going to build in a few steps. The first thing we're going to do is we're going to insert a primitive solid, and we're going to choose a cylinder cone. In this case, we're going to use a cylinder, so we make sure the cylinder option is selected. Now my radius is going to be 1.5 millimeters. It's a 3 millimeter diameter light guide. The length is going to be 25 millimeters. And my position is X equals 0, Y equals 0, Z is equal to 100 millimeters. And the base rotation is 0. Then click Insert. Now I want to modify this light guide. I want to have the light guide turn 90 degrees downward in this orientation and then be extruded or extended for another 25 millimeters. So I'm going to use the revolve and sweep options in TracePro. I'm going to expand this. Actually, before we do that, I'm going to rename this light guide. And I'm going to select the exit surface of this light guide. You can see as I click different surfaces here, they highlight in black. So surface 2 is the exit surface of this light guide. I'm going to do a right click and choose revolve. Now the angle of my revolution is 90 degrees. Draft angle will leave it 0, so we're not going to have this taper in any way. The radius of revolution will be 25 millimeters. The axis of the revolution is going to be along the x-axis. It's in and out of the screen, so we're going to revolve around that axis. And the last thing is we need to tell TracePro a position on the axis of revolution. Now actually TracePro has a nice easy way of doing this. We can click Calculate a Position using Selected Surface, and it'll automatically populate that dialog box. And then we can click Revolve Surface. And then just do a zoom all. Now here's our light guide going around the corner. Now to complete the light guide, I want to extend this end of it. And we still have the last surface selected. Notice though it's now surface 3 as opposed to surface 2. But I'm going to do a right click, and this time we'll choose Sweep. I'm going to make my distance 25 millimeters. My draft angle, I'll leave at 0 degrees. Again, we're not going to have the light guide taper in any way. And I'll leave this default setting here, sweep along surface normal. It means it's going to sweep along a normal or a right angle to that surface. So it's going to go straight down. And I can click Apply. So there's our light guide added to the model. Save it. Now the last piece of geometry I need to add is my target. It's on the output here of the light guide. So once again, I'm going to do this using an Insert, Primitive Solid, and once again I'm going to use a cylinder. I'll call it Target. The radius of this is going to be 7.5 millimeters. The length is 1 millimeter. Its position, to put it down here at the output of the light guide, X is going to be 0, Y is going to be minus 55, and Z is equal to 150. And then lastly, I need to rotate it about the x-axis by 90 degrees, so it'll lie flat here to the light guide. Then click Insert. I'm also going to go in, and I want that top surface. So actually I'm going to choose here the Surface Selection tool, and I'm going to pick the top surface of this target. And we see it highlights surface 1 here in the model tree. So I'm just going to rename that receiver. Makes it easy to find the surface in the future. So now we're finished creating our geometry. The next step is to apply properties. The first thing we're going to look at is we'll apply a couple surface properties. So for our baffle tube here, I'm going to select the tube. I'm going to do a right click, go to Properties, and I'm going to choose a black paint surface property. It's in the default catalog in TracePro for surface properties. I'm going to click Apply. Now note this dialog box is what we call modeless, so once I click Apply, it stays open. So I can go to another surface, the receiver surface here of my target, and I'm going to go in and apply a perfect absorber property to that. So all light that hits that surface will be absorbed. Okay, so now my surface properties are applied to my baffle tube and my target, And the last property I need to apply is the material property to my light guide. So I'm going to select the light guide. I'm going to go here to Material. Now this light guide, I'm going to make it out of fused silica. So in the glass catalog here in TracePro, one of the default catalogs, I can choose fused silica and then click Apply. So just to show how those are applied, if I open up, expand the light guide, we'll see it says it's from the glass catalog. The material name is fused silica. My baffle tube here, I can see that it has the black paint property. My receiver surface has the perfect absorber property. So all of our material and surface properties are now applied. But one thing I like to do, especially when I'm keeping a model in render mode like this, is I like to change the color so I can actually see things a little better. So I'm going to start off with the baffle tube. I'm going to do a right click, go to Properties again, and I'm going to choose Color. And once here, I'm going to change this. I'm going to use Custom Color. And if I click on the color bar here, I can go in and pick a color, any color I want. I'm going to use black in this case. But I also want to be able to see through it so I can see the lenses inside. So I'm going to click on Object Transparency and set that to be 90% transparent for red, green, and blue, and then click Apply. So if I click off of that, we can see our lens barrel is now a black color, and it's mostly transparent. So I want to add now some color to my lenses and my light guide. And I usually wind up using a bluish color for lenses and glass objects. Once again, I'll pick a blue, click OK, and I'll set these to be transparent as well. So in this case, I'm going to use 50% transparency. Click Apply. And the last thing is my target. Let's just make that orange. And click Apply. We'll leave it as a solid so it has no transparency. So here's our model with some colors added. Makes it a little easier to see things. And colors and transparency. So now we've gone through the first two steps in the workflow. We've created the geometry. We've defined the properties and applied the properties. The next step is to set up a source. I mentioned we're going to use array file in this case. So array files you can download from the websites of many of the LED manufacturers. And what array file is they've taken their LED or their light source and measured it with a Gaussian photometer and saved all that data. And from that data, they create what's known as a ray file. And each line of the ray file represents a single ray. And that each one of those rays will then have an XYZ starting position, an XYZ direction vector, and a flux value. What's nice about ray files is that they're based on measurements of the complete package, the complete LED in this case. So you don't need to build a model of the LED. Everything such as the epoxies, the coatings, the shape of the lens is all taken into account because they're measuring the finished product. So really you just need to insert that source into TracePro and not have to build any geometry. We did do one of our webinars of about a year ago was on accurate modeling of LEDs in TracePro. So if anybody's interested, if you go to that webinar section, you can download and see a more complete discussion of ray files, surface source properties, grid sources, and all the different ways you can model LEDs. So to use a ray file, in TracePro they're called file sources. I'm just going to go to Define, File Source, and I give it a name, LED. And then here where it says Ray File, I'm just going to click on the Browse button. And it lets me browse to where I've saved a ray file. In this case, I'm going to use an Osram LED ray file. It's a LWW5AM that I've downloaded previously. Change my file types here. And Osram will in a lot of their ray files will provide 100,000 rays, 500,000 rays, and 5 million rays. So for this webinar, I'm just going to choose the 100,000 rays and then click Open. Now we see it. We've loaded that ray file. The center position, I'm going to leave it at 0, 0, 0. And the rotation will be 0, 0, 0. So it'll be right where the ray file was created. It already has a wavelength predefined. And all I need to do now is click Insert. If I go back here to my Source tab, we'll see. It now have our LED file under ray file under File Sources. If I click on that, and I'm going to zoom in here a little bit, we can see a little red wireframe sphere. And what that does is TracePro is giving you a representation of where the rays are going to be starting from. So it's a visual representation only so you can have a feel for where that source has been placed. So the last step now, we have our source, we have our geometry, we have our properties, is we're going to run the ray trace. And we can do this either by clicking Trace Rays right here, the icon, or we can go to Ray Trace, Trace Rays. Okay, ray trace is complete, ran fairly quickly. Now, for people that may not be familiar, we can see there's a few different colors on the screen here. Then the default setting for ray colors in TracePro is flux-based ray colors. So when the rays start out, they're red, when that's with 100% flux. When that flux drops below 66.6% of the initial value, the rays are then represented by green. And then when it drops below 33.3% of that initial value, they're blue. So we can see red rays here focused onto our light guide. It's pretty much red coming out of the light guide. This blue here coming out the back could be Fresnel reflections off the surfaces of the lenses. Could be some scatter off the inside surface of our lens tube. So multiple things there, but we can tell just by the color they're lower flux rays. Now I can clean this up a bit. I can use a ray sorting feature in TracePro. I'm going to go here and I'm going to select the receiver surface, which is the one facing the exit of the light guide. And I'm going to go up to Analysis and then Ray Sorting. And I'm going to choose Selected Surface, my sort type, and click Update. So now we're only going to see the rays that are actually hitting our target surface. Makes the model a lot easier to look at. We're just seeing the rays of interest. So once we've run our ray trace, we can look at some of the analysis tools. Running the ray trace is one thing, but ultimately what you want to do is to be able to analyze the results. First thing we can look at is an irradiance map. I can go to Analysis, Irradiance Illuminance Maps. And this will show you the spatial distribution of the light on the surface. In this case, I'm in radiometric units, so I'm looking at irradiance, which is in watts per meter squared. The flux will be in watts. I could easily switch to photometric units and look at lux and lumens values. I can look at some of my options here. I can just do a right click, choose irradiance illuminance options. The first thing I might want to do is add some smoothing and then change my color. I'll do a color rainbow on black instead of the grayscale. But I can also control the number of different divisions here on the left. I'm going to increase that to 20 and click Apply. So now we see here it's the distribution of light across that target surface. It's brightest just a little bit offset from the center, which the bending the light guide causes that. Some of the additional options here I could look at, I could change this to a contour plot. I could look at a relief plot. I could turn on profiles, where now what we're seeing is a slice across this data. And here's the profile along this horizontal crosshair, and the one across the vertical. And I can move that around just by left-clicking and dragging it to whatever position I want. Another option here is I can change from irradiance to true color. And I can take a look at, here I'm seeing my results. It was a yellowish light, or it was yellow light that I picked. 0.57 microns was the wavelength. And here I can see it in true color. Now another thing I want to show on an irradiance map is a new feature from about a year or two ago in TracePro. If we go here to Analysis and then 3D Irradiance Illuminance, we can see that irradiance right on the surface in the model. Again, I can go to my options, just a right click in the model window. So turn on smoothing, increase the number of pixels so it's a little smoother image. And this lets us see that irradiance right in the model without actually having to open up a separate model window. Useful feature, you can also select multiple surfaces as well to see the irradiance on any surfaces in the model that you want. Now, another thing we can look at, I'm going to turn off that 3D irradiance. The irradiance maps, radiance and illuminance, depending if you're in radiometric or photometric units, shows you that spatial distribution. We can also look at the angular distribution of the light, the candela plots. So once again, I'm going to have this receiver surface selected. And I'm going to go to Analysis, Candela Plots. And I'm going to choose the rectangular candela distribution. Okay, now one thing I know is the data looks, there's not enough rays to get accurate results, but I know my settings are off as well. Now I'm going to do a right click and choose the options. And the first thing I want to do is I want to set the normal vector. Now this is a vector that's normal to the plot that you want to have. So right now it's along the z-axis, but we want to change it so it's along the negative y-axis because our light is pointing down in our model. And by doing that I need to change my up vector, which is simply, it's the rotation of the plot about that normal vector, and it can't be parallel with the normal vector. So I'm going to set it to x equals 1. And for my ray selection here, I'm going to use incident rays from the selected surface or exit surface. So I'm going to see the candela plot for the rays hitting that target surface. Then I can click Apply. Now we have four different profiles here. We have a 0 degree, 45 degree, 90 degree, 135 degrees. I want to simplify that. I only want to see it in 0 and 90 degrees. So basically along the x-axis and along the z-axis. I'll also turn on smoothing. Now one thing I note here is that our data, we haven't really traced enough rays to get a nice smooth curve. We'd need to trace more than the 100,000 rays we did. And actually I want to go back, if we go back to our irradiance map. If we look here at the bottom, we can see the number of rays that's actually hitting this surface. It's 15,610 rays, and we started with 100,000. So we're not this isn't a very efficient system. We can actually see the total flux, and then the flux divided by emitted flux. So this is the flux on this surface divided by the total flux, or the total output of the source. So we've got about 12% efficiency. So we don't have a lot of rays making it to our target. So going back to the candela plot, another option here is the polar candela distribution. Same information, but now it's in a polar format. And again, I can go to my options, change that to a luminaire format. People that work in the lighting industry a little more familiar with maybe with this type of a presentation. So we see the light aimed downwards in the plot. You can also go for the candela plot, an ISO candela plot. We'll do the polar ISO. Once again, I can go to Options, turn on smoothing, and I'm going to set it to have some color. as well as add some more resolution, 20 steps. Now what the polar ISO candela plot shows you, these distributions show you the polar distribution along a single azimuth angle, or in this case 2 azimuth angles. So that would be, if I turn on a pen here, be the equivalent of going through this data, taking a slice like this and a slice like this. Now with the polar ISO candela plot, we get both polar angles and azimuth angles with the candela value, or in this case the watts per steradian value, being represented by color. So this shows a more complete representation of the angular output from that light guide. But sometimes, you know, it's a little easier to understand what you're seeing with the candela distribution plots. So that's a quick look at some of the analysis tools we could look at with this model. One thing I'd like to show before I wrap up this demo is another way to do that source. Reminder here as we're going along, any questions that people may have, please feel free to send them in using that question box in the GoToWebinar control panel. What I'm going to do is I'm going to turn off my LED. I'm going to display my rays again. I'll turn off my ray sorting. And I'm going to delete my ray data. It's under the Tools menu, delete ray data. And what I'm going to use a surface source property. It's another way in TracePro for modeling a light source. So first thing I'm going to do, I'm going to go to Insert, Primitive Solid, and this time I'm going to use a block. And I'm going to call it LED, and it's going to be a 1 millimeter cube. I'm going to place it at the center of it at minus a half a millimeter. So the front face of this will be right on the origin, 0, 0, 0. I can click Insert. Here, if I zoom in, here's the LED, what I'm going to use to represent my LED. If I tumble this a little bit, I can see that surface 0 is the one facing my lenses. I'm going to call that emitter. So that's where I want my light to come from. Let's double check that's off. Okay. I'm going to go here. I'm going to do a right click and go to Properties. I'm going to choose Surface Source Property. I'm going to go up for my emission type will be a source property. And when you do this, you can now go to all the LED catalogs that are preloaded in TracePro. Cree, Luxian, Osram. This is where if you make new properties using our Surface Source Property Generator utility, you can add new LED or source properties here into the catalogs. So I'm going to choose a Cree X lamp. And let's go down. We'll do an XPE white, 3700 to 5000 Kelvin. So it's a neutral white LED. I'm going to set my number of rays to 100,000, same as what my file source was. And I'm going to set my wavelength to 0.570, same wavelength as I used before with the file source. And then click Add. And then I can click Apply. So now I can go here, I can run this ray trace. And there's the results using using a surface source property instead of a file source. Again, I mentioned the webinar that we did on accurate modeling of LEDs, and that lets you go in and, or actually if you download and watch that webinar, it talks about the pros and cons of surface sources versus grid sources versus file sources. So it's a good resource to see how's the best way to really model an LED. Okay, with that ends my live demo portion here. Oh, and before we go to questions, and once again remind anybody, please feel free to submit any questions you may have, and we'll address those shortly. But here, if you download these slides for future reference, here's the information on everything I did there. Here's lens 1, the Mills-Griot LAG119, the thickness. This is the information that actually comes in with the lens from the catalog. But here's my position and rotation. Same thing for lens number 2. Basically the same. It's the same lens, just a different position, a different rotation. My baffle tube here, steps for making that, as well as we can see here in the model tree, it has a perfect absorber property applied. And then the step-by-step method for making the light guide, the initial portion of the light guide, again, fused silica. The rotation, the 90-degree rotation to make the bend in the light guide. And then the sweep function to extend the end another 25 millimeters. Here's our target, 7.5 millimeter radius, 1 millimeter thick, position and rotation, as well as here on the receiver surface we have the perfect absorber property applied. And then lastly, setting up our file source. This here, it says RAY file. This is where the file is saved on my computer. So if you're insert 1, this is going to be different. So this will just point to where you have a RAY file saved on your computer. I note I downloaded and saved the RAY files before the webinar, since some of them can be rather large, a couple hundred megabytes. It takes a long time to download it at times. So with that, we'll have Andy come back online, and we can look at some of our questions.
All right, let's have a look. We have one so far.
Okay.
And that one is there a way to simulate sunlight source?
There is. There's a couple ways to do that. I'll go back to TracePro here. One is if I use a grid source. A grid source here, this one's predefined in TracePro. A grid source is a flat two-dimensional grid of points that emits light. But if I double-click on here to open up the options, one of the options here in beam setup for my angular profile is solar. So this will have that roughly 1/4 to 1/2 degree divergence that sunlight has. I can click modify. One thing I'm going to do is I'm going to change this to random, and I'm going to trace 10,000 rays from this source. So here's our sun source. So we could make this grid source as large or as small as it needs to fill the aperture, overfill the aperture you're trying to do. In addition, you can set additional wavelengths and weight them according to the solar spectrum that you want to use. Now another way to do this, I'm going to insert a primitive solid again. Well, let's just make it a cylinder cone at the origin, is to use a surface source property. And one of the options for a surface source property is solar. So I can come in here, and I've already predefined this one. I built this property previously. Let's go to my examples. Sun. And let's put a couple wavelengths in, 0.5, 0.75. So if I click here, my View Data button, shows me the surface source property editor, and I can see I've defined the spectral type as solar and the angular type as solar, as well as the emission, 1366.1 watts per meter squared. So very easy, you just make that surface source property, and I can apply that to any surface in the model here. So I'd make this disk large enough to fill the aperture or overfill the aperture of whatever I'm working with. And you can see here, as I define different wavelengths, it automatically weights the flux based on the solar spectrum that's defined in the background. And if you look in the TracePro user manual, I believe it's in chapter 7, if you just search for solar, it'll show you the solar spectrum and talk about where the angular distribution comes from that we use in this property. So a couple very easy ways to do that. And while I am mentioning it, a new addition to TracePro is our solar emulator. This is getting a little off topic, but it relates to the question here. Is we have a new utility that can let you define a location as well as a time period when you want to start the simulation, when you want to finish it, and it'll automatically move the sun across the sky in your model and save the results. Once again, I keep mentioning our webinars, but there is a webinar on this specific utility that shows you how to set this up and use it. Okay, go back.
And actually, is there any more questions at this moment? Because right now we don't have any.
Okay. While we're waiting for that too, just a quick note that a recording of this webinar and a copy of the slides and example files will be available shortly for download from our website from the webinar section. So please feel free. I'm not sure. It may be the end of the week that we have it up, but it will be fairly quickly. And I'll include the sample model that I built as part of the webinar. Looks like we might have another question here.
We do indeed. Can you discuss using holographic films?
TracePro really, TracePro does not keep track of things like phase angles. It can do edge diffraction, but it can't do, full diffraction effects, interference, things like that. So really probably wouldn't be my first choice for a holographic type film. If it's a specific profile that's on there, we might be able to do it using the reptile property or making an actual 3D model. But some of the effects you may see from that film won't necessarily be fully modeled in TracePro. But if there's a specific question about something like that, please drop us a note here. Here's our contact information. You need to send an email to sales@lambdares.com or give us a call at 978-486-0766. I'll be glad to work with you on that as well.
All right. I think that about wraps it up, Dave.
Okay. Well, yes, I'd like to say thank you to everybody for attending today. Look forward to seeing everybody at our next webinar. And once again, there'll be an archive copy available for download soon here.
Thank you all for attending. Have a great day.
Okay. Goodbye.